our fifth tutorial. We have to calculate the current in both the resistance, okay, by nodal analysis. We know that between two nodes one voltage source is there, so this is nothing but supernode concept, or that is supernode. So in node or supernode, what we'll do, we'll assume two voltage VA VB, okay. At A, the one simple thing is we don't know what is the current in the branch AB, so we'll assume the branch current I, okay. 3 ampere is coming from here. I'm assuming I1 is going from here, I is going from A to B. Then this I is again converting I2 and I3, okay. Now apply KCL at node A, okay. So 3 ampere is nothing but I plus I1, okay. What is the value of I? We don't know, we will put it like that. I1 value is VA by 2, so I can write I is equal to 3 minus VA by 2, equation 1. KCL at node B, so I can write I is equal to I2 plus I3. I is equal to I2 is nothing but VB divided by 1. I3 is nothing but 2 ampere, okay. So from equation 1 and 2 we can put the value of I, or we can equate. So 3 minus VA by 2 equal to VB plus 2. So I can take LCM and cross multiplication, okay. 6 minus VA is equal to 2VB plus 4, okay. So I can write 2 is equal to VA plus 2VB. Equation number 3. From supernode we can write equation VA minus VB is equal to 2. This is equation number 4. Now by equation 3 minus 4 VA plus 2VB is equal to 2, then VA minus VB is equal to 2. If I will subtract that, VA cancel, VB value is 0 volt, and VA value from equation 1 I can write not 1, equation 4, VA minus 0 is equal to 2, that means V is equal to 2 volt. Now I have VA is equal to 2 volt, so current I1 is nothing but 2 minus 0 divided by 2, that is 1 ampere, and I know this is 0 volt, so 0 minus 0 divided by 1 is nothing but 0 ampere. The I2 value is 0 ampere and I1 value is 1 ampere.